I'm trying to figure out how I can see everybody who's watching right now, and I don't really know if there's a way. So if I don't call you out by name, you'll have to forgive me. We're a little bit early. I'll start presenting at 11, but just so everybody knows, I'm here to have fun. I'm here to learn too, and kind of like Ms. Dean said at the beginning, I hope that this inspires you. If you come up with any questions as you are watching, just feel free to enter them in the chat, or you can click on people and private message me as well if you have some questions that you'd like addressed later. Yeah, awesome, Darby. So I'm not going to get too much into the code here, but a lot into the cloud and what it has to offer. Anybody else want to join in the chat before we get started? By the way, I found out that if you don't use Chrome, the chat feature doesn't work. So if you guys are watching from Edge or Firefox, I believe even, and you're having problems with chat, if you re-log in with the Chrome browser, that works. I helped a friend out with that earlier today. Oh, nice. So it does work with some versions of Edge. Good to know. So I also wanted to do a little plug for Lunavi. Lunavi is a new name for a company called Deliveron that's been in Omaha for a long time. And we are sponsoring the Mesh Party, as Deliveron does every year, as Lunavi this year. So if you can stick around, for the end, 4 to 5:30, I believe, in the same venue, there'll be a Mesh Party with some prizes. So I hope to see everybody there. Looks like it works on Firefox 80 as well. Nice. Oh, so I believe that the party is going to be hosted in one of these stages, and it's like some of the things that you'll be able to win will be coupons for liquor stores and things like that. But it's kind of bring your own alcohol as far as I can tell. Or bring your own tea if you like tea. Can everybody hear me okay? Anybody having issues with that, or is it too quiet? Great. Yeah, I'm excited to get started. What did everybody think of the Microsoft stage presentation this morning by Ms. Dean? Did everybody get a chance to watch it? How many of you are using Docker or Kubernetes already? I'm curious. That remote debugging is one of the coolest features I think that they have at AKS, and I really like the demo that she did on that and how it can use everything that's in production except for the one piece that you want to run on your computer. I think that's pretty powerful. I'm sure there's a lot of stuff you got to stitch together to get that to work first, though. Oh, Derek, that's a good point. I bet it is a little bit harder to work when everything's locked down. So, what's some of the favorite things that you do with Docker, the people that are using it already? Just curious. Oh, cool. Microservices with container registry. I saw a really good presentation by Andrew Oshner on the Three Musketeers and using Docker to not only build the app, but also the pipeline that deploys the app. I thought that was really interesting how that all worked together. Has anybody looked at that before? Yeah, I believe it was in the Omaha DevOps user group, and I don't have the link handy, but I can get it out on the chat later. Um, if you guys are interested in watching something like that too. What about .NET Core? Do we got some .NET Core users watching? Cool. Yeah, .NET Core. What I like about it is you can run it with Docker on Linux, right? And there's a lot of cool things that you can do in the cloud worlds, both on AWS and Azure. Um, Lambdas can run .NET Core natively, so that's even faster than the Python Lambdas, and that's an AWS, of course. Hey, Derek, I'm going to touch on service bus, event hubs, and storage queues, not Kafka during this talk, but it's a similar idea. What I'm going to present, you could definitely do with Kafka as the bus, if that's what you like. Yeah, what did you like about Kafka, Derek? Hey, Ben, good to see you. Hey, Curtis, good to see you too. Josh, good to see you. All right, guys, it's coming up on 11. I'm going to start the presentation. There's been a lot of activity in the chat window, so hey, Robbie. What I would like to do is try to get through as much of the presentation as possible because they're only recording for 45 minutes and then save the questions for the end. So if you guys are watching and you think of a question that you have, you can either private message me with the people feature, or just type it in the chat. And as I get down towards the end of the deck, I'll be checking out the chat again to try to answer those questions. So let's get started. I'm going to talk about modernizing applications with event-driven microservices. But first, I just wanted to thank the sponsors for putting this on. You'll notice Deliveron is there on the right in the middle, and that's where I work. We this week went through rebranding, and so now we're Lunavi. If you guys are curious, we actually have a mesh party this afternoon. So quick look here at the agenda. We're going to go through just an introduction, talk about what the problem that we're solving here is, and I'm going to use breaking down a monolith presentation that I did for a .NET user group, some of the pictures from that to kind of help frame up the problem. Talk about all the considerations that go into microservices and how event-driven really emerges, and then show a little bit of the architecture and a demo. So like I said, Lunavi is formerly Deliveron. We help business and IT leaders create custom software solutions with confidence. That's really our core strength. We work with some of the companies that are represented here and some of the sponsor companies here as well. And we just have a passion for helping, keep helping companies create high-performing delivery teams. Again, the mesh party tonight, 4 to 5:30. So you'll get cocktails on us. I don't know how that's going to work. It's going to be a surprise for me too. And then there's going to be the Weisenheimers doing some improv comedy, so that'll be fun. And you can get some prizes just from tuning in. Okay, so let's get started. In this, I'm just going to use this example of a monolith app. I'm sure that everybody here that's done any kind of development has worked on something like this. It could be an MVC app, could have a JavaScript front end even. It could even have some services in the mix, but what makes it the monolith is the deployment model. It's when you have this application, you have put little tiny change in it, but all kinds of pieces have to be tested forever, and it takes a long time to test and promote to production, and if that all doesn't go together, then it might not all work. And so what we want to do is try to move to a world where microservices can be deployed hourly, even if we needed to, without disrupting anything else going on. And so kind of like that demo this morning with AKS, I mean, that was just really cool. I hope that using a infrastructure like I'm going to present can help move towards that same kind of goal. So, the monolith, it has several data sources. That's okay. It's really about that deployment model. So what I'm going to use as an example is went into a company, and they had this big monolith, and they also had these business goals. Like, they heard this term microservice, and they said, hey, we want to do microservices, and the architects there said, hey, we've heard all these words and we want to start using this stuff. And so we said, well, let's take a thin slice off of your existing monolith and decide how we could do that and lay kind of the foundation for what microservices might look like here. And So they picked this document upload feature. They picked it for a few reasons. I'll just go over those. One is they did a kind of a tech UI refresh on a lot of the site, and this feature wasn't used much, and it got overlooked, so it was kind of outdated as far as the look and feel with the rest of the site, so revamping that part was good. Also, it went, somebody could come in and they could upload files at anybody, even somebody who's not a consumer, and those would go directly into an email-based business process, and so they felt like maybe that was a little bit insecure. And then they also needed to have ADA AA compliance, and they knew for sure that this current form had none of that. And so we kind of took a look at how we could help with that. Also, there was no existing database component, so that took out a level of complexity with dealing with microservices, and let us focus on kind of the services without the SQL database, I guess I should say. So what were the problems? It's this monolithic architecture. It was very hard to make changes without knowing what else is affected. It's compounded by the lack of unit tests. So, somebody makes a change, it's all manual, days of testing before it can actually go in. Very small amount of integration tests, they were run manually, not in a pipeline, and a lot of them didn't pass, but you just had to know which ones were supposed to pass and which ones weren't. Also, the monolithic architecture that we broke down, part of was on an older version of Net Framework, and they also had this TLS 1.2 requirement that we needed to start working towards, which wasn't supported in that 4.6. So security, had some concerns as well. They said there's unfettered access to this form, that you don't have to log in, there's no throttling to prevent attack, there's no logging, we don't know where this stuff came from, we just know that it ended up in an email. So it could be a virus, could be lots of things. And so those were some pretty big concerns. And so we kind of said, well, from the business side, what are your needs? And as any Agilist goes, you have to build something for the business to get funding, right? And so, they wanted to do the security scan, like a virus scan, or even better if we could on upload. Wanted to improve the appearance. Make it reusable for other workflows, acquire authentication from both customers with no user account or with a user account, and leads that had no account to submit documents. But they didn't want them to have unfettered access like before. And then they wanted to be able to deploy independently from the monolith more frequently, daily if possible. We've actually got that even quicker than daily, which is nice. Technical wants, so this was like the architects there, hey, we're going to do microservices, we want Docker containers, all these buzzwords, loose coupling, ephemeral data, we want unit tests, we know that's something we don't have today. We want .NET Core, we want metrics, we want monitoring, and so that all kind of weighed in. This company was already bought into Azure, so they had been doing some lift and shift of some applications from on-prem to using Azure SQL and Azure App Service plans. Okay, so let's talk about some of the considerations that went into deciding how to get to event-driven. First of all, there's an option for a direct API. That's point-to-point. So that's when you have microservice A talk to microservice B that talks to microservice C. And that might seem simple at first when you only have A, B, and C, but as your footprint of microservices grows, and I've seen this happen at places where sometimes D calls back to A, and A also calls to D for something. And then it starts to be very confusing as to what's the flow of data, who manages what pieces of data. And so there's also that the sender must know about the receiver. They have to know a lot about the receiver. And if the receiver changes, then everything upstream probably has to change as well, including that sender. Using a broker, and that's really where this event-driven or receiver-driven flow control comes in, and that could be Kafka, like we talked about before, is a different approach, and that's where the receiver controls what messages they react to. The sender just drops messages into a stream or into a topic or into a queue, and one or more receivers, depending on type there, can pull those messages in to look at and do something with. And at that point, you really just need to know, is there going to be more than one, and decide topic or queue, topic or stream for that, or if there's only going to be one, and maybe queue is good enough. So I have a picture of that, and one calling two that calls three and four. And here in green down at the bottom is that using a broker flow, where one drops something into a queue, two picks something up out of the queue, two drops something into a service bus topic in which there's two subscribers for that same message, 3 and 4. So microservice considerations. We went with function apps for this. It's not a requirement. You don't have to use function apps, but why did we choose to use them? Well, function apps have this inherent ability to bind or to be triggered from blobs, from queues, from service bus, from event hub, and there's other types of triggers that you can create that fire one message, spin up one function to handle the one message. And then, if it's using queues or service bus or hubs, if it fails and there's dead lettering or things like that turned on, then it can go back into this, a retry mechanism for a certain number of times. And I'll get into that a little bit. So we got auto retry, again, for queues topics. So when would it be good to use that? If you're writing code and you're writing it for an API, maybe you have 5 documents, they all have to be virus scanned. Would you do that in a for loop? Well, that's good. But what happens if the 5th one throws an exception? Does that abort everything that happened before with the 1 to 4 successful ones? So those are possible places where you might want to break down and drop a message in to say one document at a time and have a function just do one document. And if 4 of them succeed and 1 throws an exception, you can go look in that dead letter queue and see, hey, why did this one fail? Here's the message that came through. Here's the file that went with it. I can maybe take a look and run that locally and figure out what's going on. Other places where you might want to do it is if anytime you have to have a try catch, like you're making an external call or there's some dependency that could throw it or quite often might throw exceptions that try that built-in retry. The other thing about function apps is now they support Docker. They have the plan that specifically runs Linux and it runs Docker, and it's also a premium consumption plan. So it's consumption based. It'll scale just like the free tier, but it costs a little more. You can hook it up to, of course, it costs more than free. You can hook it up to networks and things like that if that's what your security teams dictate. And it was similar enough to the existing web app practices that were going on at this firm. So the next consideration is service bus versus storage queue versus blob triggers. So we'll talk about storage queue first. It is cheaper than service bus if you have not a lot of throughput and smaller message sizes. We're talking like fractions of a cent versus cents over service bus, right? And so it's a nice one to use, but it's important to take a look at not only the, your speed considerations, but also the considerations of cost when you're building an infrastructure like this. With blob triggers, those are great, right? You can get a file, you can trigger a function, but if it fails, that function only fired once. There's no retry logic. It fires when it's created, and that's it. And then let's talk about like single writer principle and ephemeral data. So single writer principle basically says for any item of data or resource that should be owned, it should be owned by a single execution context for all mutations. And so we wanted to at least try to fulfill some of those. And so we did, worm policies on the blob storage. And what's cool about that is worm stands for write once, read many. It's a newer feature of Azure Blob Storage, and you can set that policy and say, for X a number of days, this thing can only be written one time. And it can't be deleted or changed during that time. And so as files get uploaded, we can make sure or enforce at a infrastructure level that single writer principle is being enforced. And then, we also have this life cycle policies in blob storage as well. So as the end result we know is back into this email flow, but if we're going to do some virus scan in between, at least for this example, having those files live somewhere for a long period of time doesn't matter. So can we use lifecycle policies to just auto clean up? Even if it had a virus, it's not going to affect anything in blob storage, right? So scan it and then let that lifecycle policy take care of it. We're not going to send those in an email, obviously. So here's just some examples of how the Azure functions look. You'll see in red there, this first way in is an HTTP trigger. There's really no way around it if you got to take content from the web. But you can see, in red, we're saying, the auth level is anonymous. They have other types of auth levels. It's accepting a post, and here's the route, and there is a required field called source that goes in the route, and a correlation ID is an optional field. But then you can also see that in orange, it has an outbox queue. So it's an out, what we're going to do is write one or more messages into that queue. And so we give it the queue name, and then in your code, you can basically just say queue.add_async and add as many times as you want. And then there's like this second step that comes in, and it says, you know what, when I'm going to listen to that same orange queue that was written to, and I'm going to do something, and I'm going to send it to a green queue. And the green queue is going to listen and do something and send it to a blue queue. And the blue queue is going to listen and send it to a topic eventually. And then this goes on. And there's service bus triggers that have topics and subscription names. And so this is just a really quick look at how you can use function apps to bind to those really simply without having to write a lot of code. I don't know if you've worked with RabbitMQ or MSMQ, but typically there's a lot of errors or bugs that could happen in your queue management where you would have to go open the queue and peek at the first message, but don't pop it out, and then try to process it. And if it doesn't process, then you only peeked at it, so it stays in the queue. But if it does process, then you want to pop it out of the queue and go on to the next one. And there's a lot of potential for failure in the way that that's implemented. What Microsoft does with these function apps is they implement all that stuff for you with that retry logic. You get 10 retries, 2 minutes apart, and it's configurable as well. So then also, we talked about Docker. That was one of the needs. I'll just show you what a Docker file looks like for any, basically, Azure function. You are from the Azure functions of .NET 3. You have to know what the script root is, and you can choose to turn console logging on or off. And then you basically are copying your files into the root, and that can be after they're built in this case. So there was also some considerations on the front end and the security around that. This monolith that we were dealing with was MVC, and even had some Forms app components tagged onto it as well. And so very, very linear type of security model that way. What happens with that is that the controller is kind of the middleman. It can be secured on a network, and you can use network level security to lock down the microservice, which is one way of doing it, right? But there's also something to be said for coming direct from the browser, building a SPA app, showing how you can use a combination of cores and OAuth and JWT tokens and things, and what they're already using, Azure AD with app registrations to do, and then even using API management. I'm not sure if anybody's used that before, but API management is a pretty powerful way to create APIs, and you could put that in front of Azure Functions. You could put it in front of web apps. You could put it in front of blob storage. You could put it in front of something on-prem. And you can create a set of rules for every endpoint, like it has to have a JWT token signed by these issuers, or it has to have a JWT token with this specific audience, or it has a threshold on how many times you can call it per minute or per 5 minutes or whatever, based off of the token or based off of some header, or I want to just not allow multiple hits by the same IP within a minute, or throttle it to 3. And so all that kind of stuff is done, but you can also use APIM to pass data to the back end. So in this case, we want to make this function app work for this initial use case of where it was working before, but they thought, you know what, there's other processes in our business that are document driven, and we might want to also scan those through this same microservice. Can we make it generic enough to be able to do that? And for the front end, website that we're building here, we only want to take PDFs and PNGs and JPEGs. But for this other system, we might want to take Excel documents or Word documents. And so as APIM, you can add in headers or things like that that get passed down to the function, and it can do the evaluation of if it's the correct MIME type and things like that inside of the app code. So that's just a thought and a way that you can use APIM that isn't typically used. I just show, this is a little snippet of an APIM inbound policy. You can see that top line. It's saying, you know what, I want to rate calls 3 per 60 seconds based on IP address. So that's a way to do some rate limiting. I want to have this JWT header. It comes in as an authorization bearer token, and it has this specific audience and this specific issuer. And then you can see that set header down at the bottom. For this specific endpoint, I want the max file size to be 4 megs, and only these MIME types are allowed. And then, with cores, that's another way, if you're using SPA apps, is make sure that only, your development server or your, test environment or dev environment server or in prod, your actual prod URL can use JavaScript to talk to the APIs. And then with that cores, you also have to return back the origin, or it doesn't really work. And so there's 2 parts to the cores down on the bottom. Okay, so the last part of this is DevOps considerations. Now, this company had been working, like I said, mostly like SQL Server and IIS on-prem, recently shifted, like a lift and shift to Azure, but their team structure was still made up in such a way where they had this infrastructure team, and then they had a few app teams. And the infrastructure team deployed this infrastructure. They used Azure pipeline, sure, but it was for all app teams, and it was like a single, database or a server, and a single web app server, and a VNet, and then all the teams would write just code, and it would get deployed to that app server in their pipeline, and that was kind of the end of it. Or maybe it might run a SQL update or something like that, and that's good. They were also trunk-based, or actually they were not trunk-based in their development strategy, and we wanted to move them towards trunk-based development because, again, with the monolith, and you got all these teams working on the same app, it's really hard to do trunk-based if you're not familiar with it. And so they had all these branches, and then merge day was like merge week. And then you also have to test all that stuff integrated together, and there's back and forth there before you can go to production. And this trunk-based kind of helps alleviate that way down before you even get to the dev environment. And so what we wanted to do is kind of shift that idiom and say, you know what, let's take some of those infra people and move them onto these app teams. Let's talk about using apps and infra people, having them work together, build a pipeline that deploys not only the app code, builds and tests and deploys the app code, but also deploys all the infrastructure for each of these microservices. And so one might use Cosmos, and one might use SQL Server, and one might use only ephemeral data like queues or blobs or Kafka. And so, engineering practices, there was also this need to, we were doing manual pen testing, and that's a pretty lengthy thing. And it happened like right before it moved to prod, but we could show using pipelines and engineering practices that you can do, static code analysis or dynamic code analysis in a pipeline. And we could also scan for third-party NuGet package vulnerabilities, right? We want to definitely consider using best practices around expiring tokens and open ID and OAuth. And we still want to show how there are separations of duties. Just because I can build this pipeline or build this code that uses this infrastructure doesn't mean that I can be the one that pushes the button to send it out. So real quick, resulting architecture, up on the bottom or down on the bottom in red is this CrowdStrike sandbox. CrowdStrike's like a third-party virus scanning tool. Some enterprises here might use it, but they have this concept of a quick or a deep scan, and you basically submit it, and it gives you a scan ID back, and then you just have to keep re-asking, hey, are you done yet? Are you done yet? Are you done yet? And it could take 25 minutes. Depending on the file size. And so it wasn't very easy to think about how we could to write something around that that wasn't a microservice, really, in my opinion, or a set of microservices. And then, we're using the orange layer there is blob storage, and I'll go through that. And then the green is our eventing layer. And like I said, we chose to use storage queues, the dark green, and topics, the light green. But again, this could be Event Hub or Kafka if you needed it to be. And then the top is this microservice layer. So if you start at the top left, a document comes in, creates a manifest. Actually, multiple documents can come in. It creates a manifest that says like who uploaded it and what time and how many docs there were, and it writes them all to this inbox storage, which has this worm policy and this lifecycle policy of 10 days, and then it's gone. And then it sends one file at a time into this eventing queue. Then there's a second microservice that picks it up out of that queue, sends it down into either quick or deep scan, and gets the scan ID back, and it writes the scan receipt, we'll call it, or batch scan IDs to the inbox. And then it also starts another event and says, you know what, here's this one receipt, and then there's a poller that sits there and polls CrowdStrike for the 25 minutes if it has to figure out if the doc is done. And when it's done, it says, okay, this one is done. And if there was 1 or 5 or 10, the batcher at the very end, that dark blue color in the top 3 on the right, has this ability to know that there's 5 because it reads the manifest, and wait for the 5th to come in and make a decision. Basically, everything had to have passed the scan, or we're not sending any files to the email. Because if one was, had a virus that was caught, the others might have one that just wasn't known about yet. And so if it was good, then it adds the files to this composite, and if not, it doesn't, and then it creates a single composite file and sticks it in an outbox. And at the end of the day, that outbox has a 30-minute worm life cycle, so that gives any subscribers 30-day worm life cycle. So that gives any subscribers a month, basically, to retry if there was problems there. So why the 10 days? CrowdStrike's an external vendor. They have a 99% uptime, but that doesn't mean that they'll always be up. And so we wanted to have this ability to, let's say, it's a holiday weekend and everybody's off for 5 days, and you come back and find out CrowdStrike went down Thursday when you left, and it's Tuesday now. Well, you still got 5 days of that storage to and a dead letter queue to reprocess. And then kind of just an infrastructure diagram, how that looks. At the top in purple there is the traffic manager. It's load balancing active to 2 APIMs. And so it's using like the fastest path for data to travel at the current time. It comes into that first function that is the HTTP exposed, and then it goes to blob and queue and queue and queue and queue, and it comes out to CrowdStrike, and then it goes again to the service bus. So, but what's cool about this is we're using this geo zone redundant storage, and so you can, it actually like 20 milliseconds or less duplicates every file you write in one region to the other, and those queues are also duplicated in there. And then we're using the geo-redundant service bus, so you get that same behavior. As a message comes in East US, it can be picked up in Central and processed there. And then, you know, obviously SendGrid or most email things can work from either region. And then, you know, App Insights, we're right into that, of course. But we've also got this geo-redundant registry, and that's our Docker registry, and that lives right next to each region too. So if a whole region goes down, we're fine, but we're also, you know, using deployment zones. And so as a single zone, if you're not familiar with those, it's a separate building in the same region that's self-sufficient, and they have multiple, let's say like 7 of them or something in New Jersey, far enough apart where a disaster could take one out but not the other 6, and things can scale up over there. So the other hook in on the right in blue there is Azure DevOps, and so that's what's building all this infrastructure and all this code, and dropping it in to the container registry, which then gets replicated very quickly. Okay, so a little quote on don't talk, just act. Don't say, just show, and don't promise, just prove. I don't know if I'll prove anything to you, but I'm definitely gonna take the time now to switch modes and do a little bit of a demo. So let's see. I'm gonna have to share a different screen here, bear with me. All right. So the first thing I thought I would show is just how this works locally. And so I'm using Writer. If you haven't seen Writer, if you use ReSharper at all in your .NET journey with Visual Studio, they actually wrote a whole GUI that's cross-platform for doing development, and it works pretty well on a Mac and on Windows, and it works the same on both. So I'm doing this demo on a Mac. I like doing .NET Core on a Linux OS, so you know the Linux that runs inside of Windows is great. Linux on a Mac is good too. But you can see it started up the application. It does a lot of details on logging down here, but then at the end it kind of tells you, okay, I've got all these microservices running, they're queue triggers, and then this one here is an API trigger. And so I'm gonna navigate over to Postman and go and send you know, a request through. And so the request is just a file, pretty simple. And there's no authorization because that's taken care of by APIM, and locally I'm not having to go through that. And it's going to give me a GUID back, and I'm going to be able to use that if I wanted to go look at the ephemeral data in the blob storage. You can also see there's a lot of logging going on as it's going from queue to queue. And then I guess the other thing I wanted to say was, you know, one of these things that's important to me is doing test-driven development. So write tests along with the code. I know I tend to do it that way. I used to, a long time ago, be like, let me write the code, and then I'll do another story to write the test, or another task on a story to write a test. I just found that gold plating and things like that tend to happen when you don't write the test first, right out of the business requirement. So we got tests, they're running, they're passing. I'll show briefly going to a dev environment. And so there you can see, oh yeah, I don't have a token, so I need to, I wrote a little tool that'll generate a token for me. Update my tokens here in Postman. Oops. And so I can do, I'll just do the same document, but now I've got this rate limit exceeded. So you can see that that APIM rule is kicking in and saying, no, you get 28 more seconds before you can go again. You did three in a minute already. And that's kind of a cool feature. And then really, I guess I could show some of what it looks like. Oh, great. I had them all ready to go and I got signed out. So back in here. I guess we can just look briefly at the queuing. So if you've never used a storage account before, it has this concept of file shares, tables, and queues. And in the queues, you'll see that each one of these has a queue, and if there was anything in it, then it wasn't running, basically. And then if there is like a dead letter, what it does for you out of the box with no extra configuration is it takes your queue name, like SDU-complete, and adds a -poison to it. And so if something failed, CrowdStrike was down or something like that, I might have a manifest pointer created -poison, and then I could reroute all those poison messages back into this queue to get my retry mechanism. And you can actually do that with the function app. You can just bind to the poison and move it right back in. I guess another thing that I thought would be kind of neat is to show service bus. So if you haven't worked with service bus, basically I had this topic created for my secure doc upload topic. And then on it, I've had a couple subscriptions. So one of those subscriptions is called I failed for .com, and one is called I succeeded for .com. And you can look and see that there are messages in each. And so, of course, this success one would maybe have another microservice that picks it up and sends out an email with those attachments, and the fail might log to security system and send out an email that says, hey, your documents didn't make it to us, or something like that. And again, you could have a number of these subscriptions. So as business requirements grow, oh, this other department also wants to know about failures so they can audit possible attacks, then you can just add a new subscription, a new microservice to enter it into their system. And so what's really neat about Service Bus specifically is that they give you this concept called an explorer. And so you can actually go look at these failed messages. I can see that there's 2 in there. I can peek at them. I can look at them and see, you know, what happened. Oh, they didn't all pass the scan. Of course, that's why it made it in here. But more importantly, I get the batch ID and some information about it. And with this, I'll just briefly show how this works. I can go look at back in the blob storage. So I'm going to go to containers and then this outbox and search for the file. I can go, this composite file is going to have like all the reasons from CrowdStrike that it could have possibly failed. And so you can see the scan ID if you need to go look at CrowdStrike and figure out why. You can see the headers that came in. And there is, oh, it was malicious mock. And of course here I'm using a mock. I don't want to pay for the real CrowdStrike. So that's another cool feature, I guess, in dev. You don't have to actually pay for all those scans. You can quickly mock that service. What else? So the biggest part of this too is that that pipeline is something that we did that shift left on. And so what's cool here is I can go look at, tests, and I can see that it ran a bunch of tests. And of course, I've got all these past tests from the VS test results, but I also ran an OWASP scan as part of the pipeline. And it gave me some feedback that, hey, you know what, maybe you should set this strict transport protocol, and I could add that to APIM to get around this. And so I'll kind of dive into the details here in a second on how that works. But also we get code coverage out of the pipeline, so we can say, you know what, we're at 87% line coverage and 57% branch coverage. We could do some improvement there. And then White Source Bolt, and this is a tool that scans all your third-party dependencies, and it looks not only at the dependency to see if it's outdated or a threat, but it also looks at the license to see if that license might have changed from something that was free to use to something that you now have to pay for. And so as an enterprise grows, I've been in some enterprises before where something used to be freeware and open source, and then some company bought it and now they want to charge you for it. Like, I guess Java would be an example of that, right? They want to charge you for it. And so then oftentimes there's like this shift to be like, oh, we have to rewrite all this code to use a different DLL so we can avoid that license fee. And so this kind of helps out with that. And what I wanted to do briefly was just kind of show you some of the neat things that go on in Azure pipelines too. And so I'm going to deploy this test environment. So I'll hit review and approve. And what I like about this is Azure DevOps, it's kind of a new thing with their YAML pipelines, is they give you this way to break up stages and jobs and then steps inside of a job. And so stages might be like development, like build, test, publish is a stage, and development environment is a stage. But inside of each of them, I have two jobs, and they can run asynchronously. You can put dependencies, like here I said, you can't deploy the app service to either the primary or secondary region in test unless all of these above steps are done. So, and I can write a separate steps for service bus and APIM and storage accounts. And once all of those are done, it will then kick off those lower layers. And so breaking your tests up, your ARM templates up like that also is easier to manage those smaller pieces. And at this point, I'm just going to stop. I just wanted to kind of show all that and take a look at the question because we got about 5 minutes left. So let's go back. I'm going to stop sharing my screen here. Okay. Yeah, I can, let's see, Angel said, can you put the slides out? Let's see. I'll do that. Okay, so there's a question about, do you need KQL or KSQL to query like a database? The answer, I think Derek might have been replying to somebody above that was asking more about Apache Kafka. But if you're not pinging, I'll let you know. So the component for uploads, that was just called Postman. It lets you post directly to an API, similar to maybe SOAP UI if you use something like that. And then Paul had a question on how do you put borders around the design for your microservices to prevent over-architecting and having to manage too many? Yeah, that's a great question, Paul. I mean, one of the things that you want to keep in perspective is the more you have, keeping them detangled, right? And so that's where I really think like following those tenets of single writer principle and those tenets of using loose coupling can help, right? So if you're managing a set of queues or a set of streams or a set of topics, that's a little bit easier, and then let the devs kind of worry about how to handle each of those things. But I guess really there is a lot more doc that goes into it, and I guess I could have showed this, but one of the things that I like to do is put that overall doc for each microservice right into the Git repo alongside the code, because as it changes, as the code changes, the doc needs to change to keep up with it. I really don't have a better answer for you than that, other than it is something that you have to consider, and I think that's a great question. Oh, the markup, Brian, that was part of the function app, and I know I've only got a second left here before the recording stops, but I can reshare that. I think you might be talking about. Oh, those are my tests. Here in like upload documents, that is just the function signature. And I had it kind of outlined in red and green. So you create a class, you tell it what storage account it's bound to, and then you create this queuing all as part of that signature, and it will just feed those messages in if they come from a post or a queue. So if you look at like the Polar one, it does the same thing. It's got those two key triggers. You may have also been talking about the APIM config, and that was XML. And so that's something that you can kind of play around with in API management. I got to warn you, the developer edition is like $50 a month, I think, but it has like an interactive GUI to try to create some of those rules. Yeah, and then yeah, I think what Matthew said is true. If it is event-driven, you can definitely feed a data warehouse as one of those things. I've actually used event-driven microservices to help move data into lower environments and into warehouses where you can, take SQL Server, for example, and get a single line update, add, or delete, and pump that into a stream or a event-driven solution. And then, for lower environments, you might want to put an obfuscator piece of middleware in, and then, update it in the lower database as a component as well. As far as when microservices might not be a good fit, Matt, yeah, I think that at some point, it might be overkill. You've got a really simple, back and forth app. You have an API that might only have a single set or maybe two controllers. Is it over architecting to deal with that? If you're dealing with simple CRUD, maybe. This more event-driven stuff for me is given that ability for multiple downstream systems to subscribe when they want to. It's given or to query what they want out of a stream of data. IoT is a good use case for streaming. Anytime though that you need this free kind of retry logic, even if you're building like a web app, a long time ago, Azure came out with this concept called web jobs, and they try to get people to like put the API code in the web app and then write a web job code for maybe doing, I think the example that they used a lot was resizing an image to have a thumbnail. And so doing that while the user's waiting for the response to come back isn't very good. But if you could, kick off a second job to do that via a queue, that would be better. So there's always pieces where you might be able to break away or think about what's my potential for failure, and how is this application resilient, and using that to kind of guide where you put those lines. I just wanted to thank everybody for coming today. We're obviously 6 minutes over time here, so I'm going to call it an end. Feel free, though, to message me using the People tab, and I'll try to reach back to you individually. Who was it that asked about the slides? I think I'll just give you a email for one of those. Well, thanks, everybody.